5 years. That is the timeline that the most serious analysts of Chinese military development are putting on the question of when China will have the capability to threaten American aircraft carriers in the Western Pacific in a way that the current defensive architecture cannot reliably defeat. Not sink a carrier, not guarantee the outcome, but threaten it credibly enough that American decision-makers would have to factor catastrophic carrier losses into any intervention calculation involving Taiwan or other Pacific contingencies. 5 years is not a long time. It is less than a presidential term. It is approximately the time it takes to design, build, and commission a single Virginia-class submarine. It is about the time between now and the outer edge of the Davidson window, the period former Indopacom commander, Admiral Phil Davidson, identified as the period during which China aims to field the capability to seize Taiwan against American resistance. And it is the timeline that emerges from a sober analysis of what China has built, what it is building, what remains to be solved, and how fast the remaining gaps are closing. This video is not a prediction that China will sink American carriers in 5 years. It is an analysis of the specific technical and operational developments that will determine whether the carrier's defensive architecture remains adequate against the threat China is fielding, and what the U.S. Navy is doing right now to ensure that the answer remains yes, even as China's capability continues to advance. The DF-21D carrier killer missile has been deployed for 15 years without ever being used in combat. Its terminal guidance problem, the challenge of finding and hitting a moving ship at the end of a ballistic flight from 1,000 kilometers away, has not been publicly demonstrated to be solved in a real operational environment. But China has not been standing still on that problem for 15 years. It has been building the surveillance architecture, developing the seeker technology, investing in the data link systems, and exercising the combined arms coordination that a functional carrier kill chain requires. The space-based surveillance layer is the most visible element of China's advancing carrier targeting capability. The Pentagon's 2025 Military and Security Developments Report documented continued Chinese investment in electro-optical imaging satellites, synthetic aperture radar satellites, and ocean surveillance satellites. China's commercial imagery companies, some of which operate under arrangements that give the PLA access to their products, have dramatically expanded the frequency with which any specific ocean area can be imaged. The gap between orbital passes that previously gave a carrier hours to move outside a surveilled zone has been compressing as the constellation grows denser. By 2030, the revisit rate of China's combined military and dual-use satellite constellation over any point in the Western Pacific may be measured in minutes rather than hours, fundamentally changing the detection problem. The Type 093B nuclear attack submarine, which the Newsweek analysis of Chinese naval developments expects to achieve greater operational status beyond commissioning in 2026, represents a step toward closing China's undersea capability gap in ways that directly affect carrier targeting. A submarine that can trail an American carrier strike group provides not just an attack option, but a persistent real-time position report on the carrier's location that satellite imagery cannot match for update frequency. The Type 093B is assessed as significantly noisier than Virginia-class submarines, but it does not need to be quieter than a Virginia to successfully trail a carrier at a safe distance. It needs only to be quiet enough to avoid detection by the carrier's escorts, while maintaining passive acoustic contact on the carrier's own signature, which is substantially louder than a submarine. China's Type 041 conventional submarine, a new class identified in the September 2025 parade imagery, represents the diesel-electric complement to the Type 093B's nuclear capability. Diesel-electric submarines are not limited by the reactor noise floor that makes nuclear submarines inherently louder at slow speeds. A well-designed diesel-electric submarine running on batteries can achieve acoustic signatures that match or approach the quietest nuclear submarines at the patrol speeds where both would operate. China's interest in the Type 041, alongside the Newsweek analysis, noting growing emphasis on undersea warfare in the September parade's unmanned underwater vehicles and anti-surface cruise missiles, suggests a systematic approach to building the undersea surveillance capability that carrier targeting requires. The DF-17 hypersonic glide vehicle is the development that most directly challenges the carrier's current defensive architecture. Unlike the DF-21D's ballistic re-entry vehicle, which follows a predictable arc that SM-3 interceptors can engage at altitude during the midcourse phase, the DF-17's glide vehicle travels in the upper atmosphere at altitudes of 50 to 100 kilometers, below the SM-3's optimal intercept zone, and above the denser atmosphere, where SM-6 and air-breathing interceptors are most effective. The hypersonic gap between the SM-3's exoatmospheric intercept envelope and the SM-6's terminal phase engagement envelope is the specific vulnerability that the DF-17 is designed to exploit. The Glide Phase Interceptor program, which the Navy is developing to address this vulnerability, was still in development as of early 2026. The program has experienced funding challenges and schedule delays that have pushed its initial capability date to the late 2020s at the earliest. In the meantime, the hypersonic gap exists. A DF-17 fired at a carrier would face SM-6 terminal phase interception at the end of its flight, and possibly some SM-3 engagement early in its trajectory. But the mid-flight phase, where it is traveling at hypersonic speed in the 50 to 100 kilometer altitude band, is the zone where current American defensive systems are least effective. China's reconnaissance strike complex, the integrated system of sensors, data fusion, command and control, and strike assets that would execute the carrier kill chain in a Taiwan scenario, is the accumulation of every capability discussed above operating together. Individual components have been tested. The integration of those components into a functioning end-to-end kill chain that can find a carrier, continuously track it through a transit, compute a targeting solution, launch a DF-21D or DF-26 or DF-17, guide it to the terminal phase, and achieve a hit against a defended, maneuvering carrier is a systems integration challenge that China has not yet publicly demonstrated solving. But the individual components are advancing on a trajectory that gives the integration problem a finite solution timeline. American analysts at RAND, the Naval War College, and the Center for Naval Analyses have modeled the timeline for this integration challenge under different assumptions about the rate of Chinese progress and the specific technical hurdles that remain. The 5-year estimate that emerges from the most serious analyses is not a specific date. It is a range within which the integration of China's carrier targeting architecture, if development continues at the pace observed in recent years, could reach a level of operational credibility that demands a reassessment of carrier survivability in the Western Pacific. Some analysts put the window at 3 to 7 years. The 5-year figure is the median of the range. What makes the 5-year timeline particularly significant is its relationship to the Davidson window and to the American industrial base's ability to respond. If China achieves a credible carrier kill capability by 2031, and if the Davidson window for Taiwan invasion capability is also in the 2027 to 2031 range, as most analysts assess, then the period during which China has both the ability to coerce Taiwan militarily and the ability to credibly threaten the carriers that would intervene is the period during which American deterrence is at its most strained. This is not a theoretical future problem. It is a current operational challenge for which the planning, the investments, and the capabilities need to be in place before the window opens. The U.S. Navy is not passive in the face of this timeline. The Distributed Maritime Operations Doctrine is the most direct doctrinal response. Rather than concentrating carrier strike groups in the forward areas where they are most vulnerable to the DF-21D and DF-26 threat, DMO calls for dispersing American naval forces across a wide geographic area, operating from multiple nodes simultaneously, and concentrating firepower at decisive moments without necessarily concentrating platforms. A carrier that is operating east of the second island chain, beyond the reliable engagement range of the DF-21D, is less valuable for close-in strike missions, but is not dead. Its aircraft, extended by aerial tanking, can still reach targets in and around Taiwan. Its Tomahawks can strike targets across the western Pacific, and its withdrawal beyond the missile threat's most dangerous range reduces the probability of catastrophic early losses that the CSIS wargame identified as the most damaging early outcome. The Virginia-class submarine is the American asset that faces the least degradation from the advancing Chinese carrier kill capability. And this is why the submarine production crisis discussed in previous videos is so strategically significant. Submarines do not face the carrier's vulnerability to ballistic missiles. They operate in a medium that China's carrier targeting architecture is designed to ignore. They are the platforms that can operate closest to Chinese shores, attack Chinese naval vessels in the most dangerous waters, and maintain pressure on Chinese military operations without facing the existential threat that surface ships face in the first island chain's threat environment. More Virginia-class submarines means more capability that does not become less survivable as China's carrier kill architecture matures. The failure to produce Virginia-class submarines at the required rate is not just a force structure problem. It is a strategic problem that grows more acute as China's anti-surface capability improves. The LRASM and the Typhoon battery represent the standoff strike philosophy that the Navy is embedding into its Pacific warfighting concept, specifically in response to the maturing carrier threat. If carriers must operate from beyond the first island chain to survive, they need strike weapons that can reach targets in and around Taiwan from those extended ranges. The LRASM's 800-plus kilometer range, launched from B-2 and B-52 bombers, extends American strike reach without requiring surface ships to enter the most dangerous threat zone. The Typhoon battery's Tomahawk capacity from the Philippines extends the reach of ground-based fires. The conventional prompt strike hypersonic missile, which will eventually be carried by Virginia-class submarines, extends submarine strike range to distances where a submarine can engage targets deep inside the first island chain without transiting the most dangerous anti-submarine warfare environment near the Chinese coast. The unmanned systems investment is the longer-term response to the carrier threat. An autonomous surface vessel that can carry Tomahawks or long-range anti-ship missiles and operate in the first island chain without a crew does not create the catastrophic human cost that losing a crewed ship does. The Navy's target of 45% unmanned surface force by 2045 is partly driven by the carrier vulnerability question. If the first island chain is too dangerous for crewed surface ships, it may not be too dangerous for unmanned ones. A fleet that can project strike power from autonomous platforms operating in the most contested waters while keeping manned ships at less dangerous standoff distances presents China's carrier kill architecture with a different targeting problem than the architecture was designed to solve. The directed energy investment is the near-term addition to the carrier's defensive layering. Helios at 60 kilowatts can engage drone-vectored targeting systems, unmanned aerial vehicles used to close the carrier's precise position for targeting purposes, and cruise missiles in the terminal phase. Higher-power directed energy systems at 150 kilowatts and beyond can engage a wider range of incoming threats at longer ranges. The carrier that has a megawatt-class laser by 2031 has a defensive option against the terminal phase of hypersonic glide vehicles that does not depend on the interceptor inventory that the SM-6 represents. Directed energy is not the complete answer to the carrier threat, but it is a layer of defense that the carrier's current threat architecture lacks and that the planned investment timeline will provide. The 5-year figure that began this analysis is not a deadline after which carriers become useless. It is the estimated timeline within which China's carrier targeting architecture reaches a level of credibility that demands a significant reassessment of how American carriers are employed in the Western Pacific. Whether that reassessment produces a decision to reduce carrier deployments in the first island chain, to invest more heavily in the standoff strike and unmanned alternatives, or to accelerate the specific defensive capabilities needed to maintain carrier survivability, is a decision that the Navy is making right now in its program offices, its doctrine development centers, and its operational planning. The carrier is not going to be obsolete in 5 years. What may change in 5 years is the tactical employment concept that keeps it effective. The carrier that operates beyond the DF-21D's reliable engagement range strikes with LRASM from extended standoff and reserves close-in operations for the scenarios where the threat is manageable with the defensive tools available is not a degraded carrier. It is a carrier employed correctly for the threat environment it faces. China will continue to build the capability to threaten carriers. The 5-year timeline is real. The American response is already underway, and the outcome will be determined by which development trajectory outpaces the other. If you want to follow the specific milestones in China's carrier kill architecture development, how the glide phase interceptor program is progressing, and what the Navy's Pacific employment concept looks like as DMO transitions from doctrine to operational practice, subscribe to Navy Power Decoded. 5 years. The clock is running. The response is in motion. China's shipbuilding advantage over the United States is the macro-level context that makes the 5-year carrier threat timeline so significant. The plan commissioned 16 surface combatants in 2025. The U.S. Navy commissioned 1. The combined tonnage of Chinese ships commissioned in 2025 exceeded the tonnage of any American carrier strike group. This is not a one-year anomaly. It is a sustained trend that has been running for a decade and that shows no sign of reversing at current American shipbuilding investment levels. The carrier killer threat is the most visible and most dramatic element of China's challenge to American naval dominance in the Pacific. But it is embedded in a broader challenge of quantity as well as quality. Even if every defensive measure the Navy is taking against the DF-21, D, and DF-17 succeeds in keeping carriers survivable, a plan that has 3 operational carriers by 2028 and 6 by 2035, alongside a surface combatant fleet that already outnumbers the American surface force, presents a quantity problem that defensive measures against individual weapon systems cannot fully address. The 5-year timeline for carrier threat maturation is the specific question this video addressed. The broader question of whether American sea power can remain dominant in the Pacific across the full range of challenges China is building. Not just the carrier killer, but the quantity of surface ships, the expanding submarine force, the growing carrier aviation capability, and the improving logistics infrastructure is the question that the next decade's naval investment decisions will answer. The Navy is adapting. The DMO doctrine, the unmanned systems, the directed energy, the AUKUS alliance, the Typhon batteries, the LRASM production ramp. All of these are real responses to a real challenge. Whether they are adequate to the full scope of that challenge will be determined by the pace of investment, the decisions of the political system that funds it, and the judgment of the adversary about when its capability is sufficient to act. 5 years. The clock is running. The decisions that matter are being made now. If China's carrier kill chain matures on the timeline the analysis suggests, and if the American response investment keeps pace with that maturation, the carrier remains a viable and dominant instrument of American power projection in the Pacific. If the investment lags, if the doctrine fails to adapt, if the industrial base cannot produce the submarines and the munitions and the autonomous systems at the required rate, the 5-year timeline becomes a strategic inflection point rather than a manageable challenge. The Navy understands this. The question is whether everyone else does. The 5-year figure deserves one additional dimension of context that makes it more nuanced than a simple countdown to obsolescence. The carrier kill chain that China is building is not a binary capability. It is a probability distribution. At the current state of development, the probability that a single DF-21D fired at a defended carrier achieves a hit is assessed by most analysts as low. As the surveillance architecture improves, as the seeker technology matures, as the data link problem is solved, as the combined arms coordination is exercised and refined, that probability increases. It does not jump from low to certain at a specific date. It rises continuously as each component of the kill chain is improved. The 5-year timeline is the point at which the probability may cross the threshold where it shapes American decision-making in a Taiwan contingency, not the point at which carriers become useless, the point at which the expected value calculation for deploying carriers in the first island chain changes enough to require a fundamental reassessment of employment doctrine. A probability of carrier loss that was previously too low to drive operational planning becomes, at some threshold, high enough to dominate it. The Navy's goal is not to keep that probability at 0, which is not achievable. The goal is to keep it below the threshold where it becomes decision determinative through the defensive investments, the employment doctrine adaptations, and the alternative strike capabilities that the current modernization program is building. Whether that goal is achieved in the 5-year window depends on the competition between China's kill chain development and America's defensive response. That competition is ongoing. The outcome is not predetermined. What is predetermined is that both sides are making the investments they believe are necessary to win the competition. China is building the surveillance architecture, the seeker technology, the hypersonic glide vehicles, and the combined arms integration that the kill chain requires. The Navy is building the interceptors, the directed energy systems, the unmanned alternatives, the standoff strike capacity, and the employment doctrine that keeps the carrier survivable and effective despite the maturing threat. 5 years. The competition continues. The Navy is in it.